The topic to be discussed here is a triangular wave generator. Triangular wave generator. A triangular wave can be simply obtained by integrating a square wave as shown in figure. This is the square wave generator. Generally, square wave generator is the stable multivibrator. This one is a stable multivibrator. Stable multivibrator has two unstable states. It continuously switches between two states. That means plus V set and minus V set. Plus V set and minus V set. This is the output of the stable multivibrator is a square wave. The square wave is applied to integrator circuit. The square wave is applied to integrator circuit. The output of the integrator circuit is a triangular waveform. Integrating a triangular wave can be simply obtained by integrating a square wave. Here we use some, for stability purpose, we use some RF here. Feedback resistance. Feedback resistance. The drawback of the circuit is more number of components are used. We go for another one, another triangular wave generator, another triangular wave generator using less number of components as shown in figure. Using less number of components. It is basically consists of two level. This one is a two level comparator. Two level comparator followed by two level comparator followed by an integrator. This one is integrator. Two level comparator is also called as a non-inverting comparator. Non-inverting comparator because that divider by the voltage at point P is connected to non-inverting terminal of the op-amp compared to 0 volts. This is called as a two-level comparator or non-inverting comparator. The output of the two-level comparator is a square wave. It has two states, plus V set and minus V set. Output is V0 dash. This one is integrator circuit. Here output of that integrator circuit is a triangular waveform. Output of the integrator circuit is triangular waveform. Here we use a practical integrator circuit. Here we use practical integrator circuit. A stable multivibrator followed by practical integrator circuit. Here two level comparator followed by ideal integrator circuit. This one is ideal integrator circuit. Ideal integrator circuit. The output of the comparator A1, this is the comparator A1, is a square wave of amplitude plus or minus V set. Plus or minus V set. This is the output of the comparator A1 is a square wave of amplitude plus or minus V set and is applied to, this one is non-inverting and is applied to the non-inverting terminal of the integrator. This one is non-inverting terminal of the integrator A2 producing a triangular wave. The triangular wave is fed back as input to the comparator A1. This is the triangular wave is fed back as input to the comparator A1 through a voltage divider R2, R3. The triangular waveform is fed back to the input of the comparator through a voltage divider R2 and R3. Let us consider power is switched on. Therefore, output V0 dash is equal to plus V set. Output V naught dash is equal to plus V set. Draw that waveform here. Plus V set. This one is output plus V set. Let us consider that output of the comparator A1 is at plus V set. The output of the integrator A2 will be a negative going ramp. The output of the comparator is a negative going ramp. This one is from 0. Negative going ramp. This one is a positive going step. Positive going step is applied to an integrator circuit. The integrator output is a negative going ramp, as shown in figure. One end of the voltage divider, that is R2, R3, is at a voltage plus V set. One end of the voltage divider means R2, R3 is the voltage divider circuit. One end is here initially plus V set, and the other at the negative going ramp. Other at here, other at is a negative going ramp of A2. At a time t equal to t1, this one is at a time t equal to t1. When negative going ramp attains a value, this one attains a value some V ramp. Attains a value V ramp. The effective voltage at point P, that means VP, becomes slightly less than 0 volts. Becomes slightly less than 0 volts means below that 0 volts. That is VP is negative. VP is negative here. This negative, whenever that this one is VA. VA is less than 0. Here 0 volt. Negative means VA is less than 0. Slightly less than 0. This switches the output A1. This switches the output A1. Output A1 from positive saturation to negative saturation level minus V set. Positive saturation to negative saturation level minus V set, like that. This one is minus V set. During the time when output of A1 is at minus V set, during a time T1, the output is at minus V set. The output of A2 increases in the positive direction. Here this one is minus V set. Minus V set means negative going step. Negative going step here. Negative going step here. Therefore, the output of A2, whenever that negative going step is applied to an integrator, the output of that A2 is positive going ramp. Positive going ramp. The output of the A2 increases in the positive direction. Increases in the positive direction, like that. At that instant, T is equal to T2. Positive direction. At that instant, T is equal to T2 here. At instant T is equal to T2. At instant T is equal to T2. The voltage at point P here, the voltage at point P becomes just above 0. Becomes above 0 means this voltage, positive going voltage here, crosses the 0.0 volts and fed back to that point P shown in figure, that is positive. At point P becomes just above 0 volts. Thereby switching the output voltage A1, 0 volts means here VA is greater than 0. VA is positive. VA is greater than 0. This one is VA compared to this 0 volts, that is greater than 0. The output is A1 switches from minus V set to plus V set, minus V set to here. This one is plus V ramp. This one is plus V ramp. The cycle repeats and the generates a triangular waveform. The cycle repeats and generates a triangular waveform. This one is like that. Generates a triangular waveform like that. This one is triangular waveform. Consider t equal to 0 point here. T is equal to 0. T by 2. T is equal to T. T is equal to T. T is equal to T. From T is equal to 0 to T is equal to T by 2. Input voltage is minus V set. Input voltage is minus V set. This is the positive going ramp. This one is negative going ramp. Whenever the output is at whenever that output of the A1 is at minus V set, that is input to that integrator circuit. The output of the integrator circuit is the positive going ramp. The output of the integrator circuit is the positive going ramp. That value attains plus V ramp. The output of the A1 is at plus V set. The output of the A1 is plus V set. The output of the integrator circuit is a negative going ramp. Attains a value minus V ramp. Attains a value minus V ramp. Here, some current directions are indicated here. This one is I2. This current is IB plus. The current flow through this is I3. Apply KCL at this IB plus I3. IB plus is 0. We know that. Therefore, I2 is equal to I3. I2 is equal to I3. I2 is equal to V0 minus VP. This voltage is VP. V0 minus VP by R2. And I3 is equal to VP minus V0 dash. VP minus V0 dash by V0 dash by R3. VP minus V0 dash by R3. We know that VP here 0. VP is also 0. VP is equal to 0. Inverting terminal of that op-amp A1 is connected to ground. According to virtual ground concept, at positive terminal of that op-amp, that voltage is 0. Here also 0. VP is equal to 0. Therefore, V0 by R2 is equal to minus V0 dash by R3. Find out V0. Therefore, V0 is equal to minus R2 by R3 V0 dash. Minus R2 by R3 V0 dash. V0 dash is the output of the A1. Maintains two levels, plus V set and minus V set. Let V0 dash is equal to plus V set. Let V0 dash is equal to plus V set. Therefore, output V0 is equal to minus R2 by R3 V0 dash. V0 dash. This one is a negative going ramp. This one is negative going ramp. This value is minus R2 by R3 V set. Minus R2 by R3 V set. Minus R2 by R3 V0 dash. V0 dash. this one. And let V naught dash is equal to minus V set. V naught dash is equal to minus V set. This one. V naught dash is equal to minus V set. Find out V ramp. Find out V ramp value. That means V naught. This value is minus. This value is minus V ramp. V naught is equal to minus R2 by R3 general X minus R2 by R3 V naught dash is minus V set, minus into minus plus R2 by R3 V set. This one is V naught. This one is plus V ramp, plus V ramp, plus V ramp. Peak to peak value of the triangular waveform. This one is plus V ramp. This one is this one is plus V ramp and this one is minus V ramp. Peak to peak is plus V ramp minus of minus V ramp. V output voltage is equal to V output is equal to peak to peak VO peak to peak triangular waveform plus V ramp minus of minus V ramp. That is plus V ramp is equal to V sat R2 by R3 V sat minus of minus V ramp is equal to minus R2 by R3. This one is minus V ramp. Minus R2 by R3 V set. R2 by R3 V set. This one is V naught dash is this V set. Finally, that V naught peak to peak value is equal to 2 R2 by R3 V set. V naught peak to peak value. V naught peak to peak value. This is the ideal integrator circuit. For ideal integrator circuit, output is the minus 1 by R1 C1 integral 0 to T Vi of T dt. Vi of T dt here. Vi is V naught dash. Vi is V naught dash. Here T is equal to 0 to T is equal to T by 2. That value, this one is Vi or V naught dash. V naught dash is the input to that integrator circuit. Vi is minus V set during that interval. Therefore, find out V naught. V naught peak to peak is equal to minus 1 by R1 C1 integral 0 to T by 2 minus V set dt minus V set dt. That is equal to 1 by R1 C1 V set integral of 1 dt is T 0 to T by 2. 0 to T by 2. That is equal to 1 by R1 C1 V set into T by 2 V naught peak to peak. Here V naught is 2R2 by R3, 2R2 by R3, 2R2 by R3, 2R2 by R3 into V set is equal to 1 by R1 C1 V set T by 2, T by 2. V set and V set gets cancelled. 4 here 4 R1 R2 C1 is equal to T R3 is equal to T R3. Therefore, time period T is equal to 4 R1 R2 4 R1 R2 C1 by R3. F is equal to R3 by 4 R3 by 4 R1 C1 R1 C1 and R2. This one is R3. This is the frequency of oscillations. This one is the frequency of oscillations. With this, the derivation is completed. Coming to function generator. What about function generator? Function generator. First one is a two-level comparator. Two-level comparator. Non-inverting comparator is the output of the two-level comparator is a square waveform is applied to integrator circuit. The output of the integrator circuit is triangle. The triangle waveform is given to one circuit. Therefore, the output of that this circuit is a sine waveform. Sine waveform. Function generator is used to generate triangular waveform and sinusoidal waveforms. How to obtain that sinusoidal waveform? By using the circuit, extra circuit. A triangular wave is input to that this circuit, and output of the circuit is a sine waveform. The shapes are curved like that. The shapes are curved like that. We will get a square wave, sine waveform. The shapes of the triangular waveform. This is the triangular waveform. Curved at the ends like that. We will get some sine waveform. We use some extra circuit here. Got sine waveform. This is the function generator description.